Kia ora guys, this is a video that was a request from Henry and it's out of the ancient Delta textbook. It's such an old scholarship question. I can't imagine there's any copyright issues with Pearson, but I guess with Pearson you never really know. Hopefully it's okay. So the question goes like this. We've got a complex number and it's on the unit circle. Right, so just looking in here, we know that r is equal to 1. The first two parts of the question I'm not going to do in this video. They're reasonably straightforward. We have to use De Moivre's theorem to show that this is true, and then do the same thing for this and this. And then we quite quickly get to these results here. If you want me to do a video on those, let me know. But I think most of you should be fine with those. Then the tricky bit. Okay, so assuming that Z lies on the unit circle with I'm having trouble with my words, with a magnitude of 1, so it's on the unit circle, right, then we have to solve the following equation. So we know that our complex number is here, right, so somewhere on the unit circle where r is equal to 1. This is my equation. Now, I'm going to show you a couple of dead ends because I want you to be thinking about what you'd try. So I want you to pause the video and try this question on your own first. First of all, try it assuming you didn't have any hints, and then remember that it's part 3 of a question that's got this stuff in here. So this is the key to making this question doable. Okay, so the first thing that you might want to try, if you hadn't had any of those hints, is just to try the factor theorem. One of the reasons to do that is it makes your brain start noticing, hopefully, patterns. The trouble is here, we know that r is equal to 1, so z is equal to cis theta. So unless r turns out to be 1, or I, or this, then it's going to be something gross, and the factor theorem is not going to work. But let's just try it to see what happens. So if we put in 1, we get out 5 minus 11 plus 16 minus 11 plus 5. And that does not equal 0. But what hopefully that makes you notice, if you haven't already, is that these coefficients have somehow got some symmetry about them, right? So we've got a 5 here and a 5 here. We've got an 11, negative 11 here, negative 11 here, and then we've got a 16 sort of just sitting there in the middle. So that might make you think of Pascal's triangle, or it just might make you think of, I don't know, some kind of seesaw thing. But that's where we're going to start. Then we've also got this hint here. So again, I'm not jumping straight to the best thing to do here. I want to show you another dead end. If you don't want to see the dead end, of course, feel free to skip. So there's my equation. And I'm told that z to the power of n plus 1 over z to the power of n is equal to 2 cos of n theta. So one thing that I might try and do is that I've got z to the power of 4 here, but I don't have a 1 over z to the power of 4. What I could do is divide everything through by z to the power of 4 and see what I come up with. So if I do that, I get 5 minus 11 over z plus 16 over z squared minus 11 over z cubed plus 5 over z4. So this is starting to look like we might have something to work with. We've got this equation here, and we've got our original one. So let's call this one equation 1, and this one equation 2. I can add these together now, and let's see if that works. Adding them together, I'm going to match up this and this. So I'm going to have 5z to the power of 4 plus 5 over z to the 4. Minus 11z cubed minus 11 over z cubed plus 16z squared plus 16 over z squared. So this is starting to look like maybe we're going to get somewhere. Minus 11z minus 11 over z, and then kind of annoyingly I've got plus 10. But if we clean this up, this is what we get. Right, I'm putting all of this in because doing scholarship questions is often going to require you to go down a wrong path. And it's really easy to think that that's bad. But this might turn out, and this is a wrong path here, well, at least it's a path that didn't get me very far. In another question, though, this approach of adding the two equations together might be one that works. So that's all good, and now I can start replacing things. This is just applying that result that we developed in part 2, plus 16 times 2 cos of 2 theta minus 22 cos of theta plus 10 equals 0. So we can divide that through by 2, but we still have a problem, right? We have a whole lot of mess. So we've got this, 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 and this. When we've done a bit more trig, there are going to be things we can do here. So cos of 4 theta, we can deal with by thinking of that as cos of 2 times 2 theta. If you're watching this in my class, we've only just seen the double angle formula for cosine, so you might not be spotting that straight away yet. Later in the year, though, you'll see that straight away, as that is something we can work with, right? And this is something we can work with. The one that's a little bit painful is the cos of 3 theta with this one here. But we can, again, later in the year, we can try doing sums to products on it. So I did all of that, and I got into a huge mess. Then I went away for a wee while, and I came back to it and thought that I must be missing something. And if you go all the way back to the equation, notice again that you've got a symmetry in the coefficients. And think back to the picture I drew up here of a kid's seesaw, right? So we've got this here with this. We've got this with this. And this is kind of like the balancing point. So rather than divide through by z to the power of 4, we're going to try dividing through by z squared. That gives me 5z squared. Now I can divide through because I know, by the way, that z is not equal to 0. So that's how come I'm comfortable doing that. Otherwise, that's usually dividing through by z squared is a big no in scholarship questions or level 3. So we've got 5z squared minus 11z plus 16 minus 11 over z plus 5 over z squared. And this is the moment in this problem where you should suddenly feel really, really happy, because we now have something that's going to turn into a quadratic. So let's go down to a blank bit of space in my OneNote and work that through. So we've got to this 5z squared plus 5 over z squared minus 11z minus 11 over z plus 16 equals 0. Right, I want you to pause the video and I want you to go the whole way through with that as far as you can. And I want you to write your answer as rectangular complex numbers. So I want it as z equals a plus ib. The question didn't state that, but there's just quite a cool thing that happens at the very, very end. But you've got a bit of work to do before you get to that. Okay, so we've got 5 times z squared plus 1 over z squared minus 11 times z plus 1 over z. I realise that looks like a 2, plus 16 equals 0. This is 5 times 2 cos 2 theta minus 11 times 2 cos theta plus 16 equals 0. Dividing everything through by 2, I don't know why that's happened. Let's just fix that. We have 5 cos 2 theta minus 11 cos theta plus 16 is equal to 0. I've done something wrong. Oh no, that's right. Okay, so I haven't got a quadratic yet, but this is a double angle. So this is going to be replaced with 2 cos squared theta minus 1. I'm doing this replacement because I know that if I do that, I'm going to generate a quadratic. The other two options for double angle are 1 minus 2 sine squared theta, which we use a lot as well. And then the less useful, except when we're really desperate one, is this third version of it here. Okay, but we don't want those today. So substituting this, then doing the rest of that line, gives me 10 cos squared theta minus 11 cos theta. What have I got now? Something tells me I've made a mistake. Yeah, I have made a mistake. Okay, hopefully you're noticing how easy it is to make mistakes. So let's just check. Here I've divided through by 2, but this is the problem here. Right, so backing out the 16, magically replacing it by 8. And now I've got take away 5 plus 8 gives me plus 3 equals 0. And we're down to a level 2 quadratic. And I'm kind of at this point hoping it will factorize, right? So I've got two numbers that times to give me 30 and add to give me negative 11. The pattern has got to be a minus minus if it's going to factorize. And those two numbers will be 5 and 6, negative 5 and negative 6. And that's how we break down that middle term. So 10u squared minus 5u minus 6u plus 3 equals 0, right? Because this is a scholarship video, I'm going to go straight to doing that factorization. So boxing that up, I get 5u times 2u for that bit, and then 5u take away 1 there. I'm doing the rest kind of by inspection and sort of checking back. So here that's got to be a minus 3. That gives me 5 cos theta is equal to 3, or 2 cos theta is equal to 1. And here I want to show you how we can use Pythagoras and a diagram to go directly to rectangular form. So cos of theta is equal to 3/5. I could go on my calculator and do this, and I'll get some horrible decimal number in there, right? But we're not going to do that. Instead, what I'm going to do is I'm going to draw a tiny little Argon diagram. Cos of theta, so I know that I'm somewhere here. Cos of theta is equal to 3/5. So that gives me here, this, and this. So 3 here and 5 here. I think I'm doing that right. Yeah. And so that's my angle there. And that means that I've got a 3, 4, 5 triangle. The trouble is that I know the length here is not 5, but it's 1. So I can scale everything down by dividing by 5. And that gives me theta is equal to, well, we don't actually find what theta is, right? That gives me that this z value is equal to 3/4 plus 5/4 of I. So that's one of my solutions. And then I'm going to do the same thing here. Cos of theta is equal to 1/2. So here's this angle. We've got 1 here, we've got 2 here, and we've got √3 here. But it's on the unit circle, so we divide everything by 2, and that gives me z is equal to 1/2 plus √3 on 2i. So at this point, you're probably feeling pretty happy with yourself. You found 2 solutions, and then you look back at the start of the question and you realize that there's a small problem, right? So just pause the video and go right back to the start of the question. And I'm actually just checking that the book had all of this. Yep, it did. Right, so what did we start with? Well, we started out not with a quadratic. We started out with a quartic. And we know that it's got real coefficients. So it's got to have 4 roots, not 2 roots. So we're not quite done. But the conjugate root theorem will rescue us, and we can say straight away, by the conjugate root theorem, z is equal to 3/4 minus 5 over 4i, and the fourth root is 1/2 minus √3 over 2i. So there you go. There is loads of really great stuff in that question. All kinds of bits of complex numbers getting pulled together. So make sure that you have had a look at this. No point me saying this, because if you're watching this far, you've definitely had a look at it. All right, talk to you later.